Hi, my name is Doug Vogt. This is the second in the video 1 series, 1B. And I'm going to be covering how I found the clock cycle, which is basically the secret of the universe, the 6 blank periods in space, and then how I found the cycles on the sun, as well as 3 others. I have a total of 5 physical evidences that this clock cycle exists. There'll be no question in your mind that it does. So let's start in. Here's a nice couple on the road to life. How do these 2 people, or any of us, know that we're in a created reality? Now, the way you do it is you look for cycles that are in existence that shouldn't logically be there. That's what you have to look for. Some of the stuff I took from my first book, Reality Revealed, 40 years ago, and I had almost all the things correct, except I didn't know the exact number of days. I knew these reversals happened roughly every 12,000 years by the physical evidence plus the mythologies. But I relied more on the physical evidence, but the mythology shouldn't ignore either. It's really our ancestors screaming from their graves that something terrible happened to them. Okay, lesson 1. I know you've all been taught, at least in school, that you have an ice age when the temperature dropped 5 degrees centigrade, which is ridiculous. This could be Seattle. It could be the Olympics, and this could be the Cascades, and Seattle's down there someplace. Now in Seattle we had an ice field that was estimated to be 4,000 feet thick. So you have to ask yourself, how do you get an ice field 4,000 feet thick? This is Chem 1A, by the way. This is not really excessive learning. You have to have snow. How do you get snow? You got to have clouds. How do you get clouds? Well, it's water vapor, condensed water vapor. How do you get condensed water vapor in the atmosphere? You have to have heat. So in order to have an ice field 4,000 feet thick, and we know this ice field was deposited within 40 years. We know that from sediment deposits in Lake Erie and Lake Michigan and Superior and stuff like that. So we know it was deposited quickly. So I actually once calculated how much pressure a 4,000 foot column of ice would be. It turned out to be like 105 tons per square foot. And the reason I mention it is we had hardpan about 4 to 6 feet down. I was kind of on the side of a hill, a gentle sloping hill. And this hardpan looked like asphalt. It was even hard for the backhoe to break through it. But after it was exposed to the earth for a while, it started cracking up a little bit. But it looked like asphalt. When I lived in Los Angeles, San Fernando Valley, we had hardpan at about 2 to 3 feet. And 2 or 3 feet of soil isn't enough mass to create pressed soil, which is hardpan. But if you had an ice field of maybe 400 or 500 feet thick for 40 or 50 years, it would be enough. Anyway, so this is what gave me the break. I came across an article by Bart Bach, an astronomer. He's now no longer with us. And these little black spots here, he found over 450 of them cataloged. And he made the assumption, he's the one who made the assumption that it was like a brand new star, a protostar, the dust shell congealing together. To me, it didn't make any sense because I'll explain. This is Galaxy M51. Now Milky Way supposedly is 30,000 light years from the center of our galaxy. So let's say 30,000 light years. That means our sun made a trip like this. That's a long time. I mean, our sun's produced 9 planets. It's been around a long time. So anyway, dear old Bach had found 450 of these in all directions of our solar system, and between about 13 to 15,000 light years of what he estimated. So I said, that can't be. It makes no sense to have brand new stars in the same neighborhood as a really old star. So I said, okay, maybe the star novas, and it doesn't destroy itself like we were taught in physics and astronomy, but rather it just expels its dust shell, and you were left with a star in the middle, but without a dust shell, which is this matter shell which creates most of the light. So I went to the University of Washington library. I told you in my introduction video, I spent a lot of time in libraries. And between Sky Atlas 2000 by Cambridge Sky Publishing and Michael Rowan Robinson, the cosmological distance ladder, blah, 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 I did a database of all known stars, open clusters, and globular clusters in our galaxy. Talk about needless, repetitive work. It was a pain on the rear end doing the database, but this is kind of what it looks like. Now I've truncated some of the stuff. There's a lot more to it, but I'm just showing what I did. I basically put a 0 and 1 light year before or after this so you could see the blank periods, but this is what I came up with. And it would go like this. This was the second. The first is 11,000 something. I'll show you later. The second, third, fourth, fifth, and sixth blank periods. And now when you graph it, the reason why I went to 0 so I can graph it and you'd actually see it when it go to 0. So this is what, I'll go on this side. This is the first one. Now, we are here. This is where our solar system is. We're a fixed point. This is a variable point. Now, I called up one of the astronomers at the University of Washington and I asked him, what do you think the error is in the redshift calculations to figure out where these things are? And he said probably a 10% error. Well, it turned out it's only like about 2.5%, which is pretty good. So we have the first one here, and this is the number of stars that were in the database for these areas. Second, third, fourth, fifth, and sixth blank periods. Now, when you translate it, this is what it comes out to. The first one was 11,742 light years away. Now, this is where between our fixed point and the variable point, so that would be off about 200 and some odd light years. But from the first to second, the error drops out because it's from variable to variable point. So it was 12,068 light years between the first and second. Between the second and third, 12,068 light years. Between the third and the fourth was 12,068 light years. Between the fourth and the fifth, they didn't have any. They probably didn't photograph any or log any. And then finally the sixth at 71,000 light years away. From the fifth to the sixth, 12,068 light years. Now I'll tell you, I don't have to go any further than this to prove the universe is the product of information. You're looking at the clock cycle. Nobody knew to look for it because you have to have the philosophy first to know to look for it. This is the second place I found it. Our good old-fashioned sun. Solar cycle is 11.09 plus years. Gleisberg cycle. The astronomer Gleisberg had noticed that the sun's output increased in a period of 8 cycles. Here's the last one. Started in 1880s, 1850s. The first in the series is the least, and it goes up progressively greater and greater until this one. This is the one that was in 1957, December of 57 and January 58. And then it drops down again, but the first here was a lot higher than this one. And this one's a lot higher than the second one, etc. So, this is where I'll get on this side now. This is where it gets interesting. So a Gleisberg cycle is basically 8 sunspot maxims, or 88.73 plus years. 136 Gleisberg cycles is 12,068 light years. Light years by 12,068 years. Any computer programmers there, hardware guys or software guys, knows exactly what I've just explained. I'll tell you. Sunspot cycle is a resynchronizing frequency. The Gleisberg cycle is a synchronizing frequency, and all geared to the main clock cycle. That's what you're looking at. It's irrefutable. Now, I object when scientists wind up doing an average sunspots or area sunspots over a month. It's a mistake, really, because it misses what the real problem is, what you should be scared about. This is Sunspot Numbers 1957. We used to get books like this. I used to get monthly reports, which had the number of sunspots, the area of the sunspots were equally important. Anyway, so look in December, from the, what was it, I think the 23rd to the 26th, 316 sunspots, 343, 355, 355, 337. That's how many sunspots in one day. Got it? The sun went nuts. Now, this is important because to figure a great secret out, you have to know some event in time, caused naturally or by a group of men or a country, that caused another group of people to do something about it. And that's the key right here. When I get into that subject, which is going to be in video series 4 on the cause of the Ice Age, is when I'll cover the greatest secret this country has. You'll enjoy it. The next way of dating this thing, since I explained what causes the Ice Age, this is what's called glacial till. And a bunch of, you can always tell the rocks are well-rounded. This is usually granite. And usually, many times you'll find logs in there, or tree stumps, or smaller limbs, or even organic material from dead animals and stuff like that. And the scientists, geologists, were able to carbon-14 date the stuff. So this gives you an idea how it, as a glacier recedes, this is a terminal moraine. The glacier actually acts like a bulldozer and pushes stuff. And in here and in these lumps here, you find this glacial till as it drops it. It melts away, it drops it. So just let you understand what the mechanism is that's going on here. So, again, I read all the journals, Science and Nature and Geology and others. Now you're going to see how I compiled it. Now, this is only a small section. I could have had 4 to 5 times more sightings, but it was getting ridiculous. So what this table is, shows you the sample, mostly wood pulp, logs, shells, peat, organic material, etc. This is the location, everything from Charlotte Island, Iran, Canada, Chile, Italy, Greece, all over the world. This is the carbon-14 dating here. It's all centered around 12,000 years ago. Here's the author, the journal, the volume, the page number, and the date. This you'll see in the Judgement book, as well as the book I showed in the beginning, The Theory of Multidimensional Reality. No, I take that back. I didn't put it in the last one. It was only cared about the cycles. It's in chapter 8 of this book, of God's Day Judgment book. Okay, that's 12,000. Here's 24,000. Glaciation, shells, obsidian, goes on from there. And all grouped around 24,000. Here's 36,000. Here's the samples, organic material, peat, bison bone, peat moss. Scientists, all grouped around 36,000 years. You see, plus or minus 2,000, 3,000. It's kind of hard to wind up carbon-14 dating this stuff. There's a number of variables. They do a pretty good job, though. And again, you can easily check the references. You'll see for yourself. And I could have had like 4 or 5 times this. 48,000 years, wood, peat, organic material, Michigan, Washington, Ohio, Russia, New Guinea, all centered around 48,000 years. 60,000 years, peat, organic material, again, around 60,000 years ago, journal Science. 72,000 years ago, wood, peat, organic material, and coral. From Jamaica, Washington, Wyoming, Wisconsin, and New Guinea, of all places. That was the shocker. There was actually a glacial till and moraine in Papua New Guinea. That's 2 degrees north latitude of the equator. You got it? They had a glacier there at about, I think it was like 5,000 or 4,000 feet. And I know the snow didn't stop there. It was all the way down to sea level. It gives you an idea of the vastness and the scope of this ice age. Here's non-glacial evidence found by geologists again. Lake muds, marine mud from all over. Sweden, Mexico, UK, US, Sweden. Again, 12,000 years, all centered around there. Here are 24,000, 48,000. This is volcanic material. When a volcanic lava flows, if there's a log underneath or below the dirt but close enough, it'll burn or turn to charcoal. And geologists will be able to find it and carbon-14 date it, and that's the technique that was used here. Again, 12,000 years, no problem. So in other words, the reason why it's in the book is because at the time of the reversal, the volcanoes also go off, and I'll explain why in video series 4. 24,000 years, 36,000 years, 48 and 60,000 years, all volcanic material. The last one, I just got a copy of GSA Today, which is a geology magazine we get once a month. And there was an article there regarding dating marking the shorelines and how the water receded using the Amorites, which live within a few feet of water of the shore. So that was the principle behind them studying. This is what they look like. And I had to turn this thing sideways because it was just, it's presented long. And also what I did is I moved the sea level thing up to, you can see the period. This is Jurassic, Triassic, goes back to 205 million years ago. There's early Jurassic, and then there's, you'll see the next one. This is polar reversal stuff, main polar reversals. This is where they try to identify the reversal. Sometimes, let's say reversed normal, there was this like now, reversed normal, reversed normal. But many times you'll see multiples within this period of time, because it's very hard to tell, especially as far back as 180 to 200 million years ago. But the key part is this, right here. The shoreline receded by 204 meters or 663 feet. I took another sampling here, 623 feet. But these are all during a reversal. Most of the, I would say all of these are by reversals. Here's one, 583 feet recedes. 553 feet recedes. But notice, further back in time, it receded more as we go further up, more recent. Here's Jurassic middle period and late period. Again, they all happen during reversals. But look how fast it drops down. Now, all of a sudden, the shoreline within a day or so drops down and recedes 658 feet, or 600 or 468 feet back. So, anyway, you could see highly variable polarity. Notice they had so many here, they just did this. And these all happen during the reversal. Because why? Why did the ocean water go down? Hey, when the sun novas, it's going to evaporate a lot of water. I figured at least 700 or 800 feet of it. That's why it went down. Every single time. Main point is, of both these, you can see, this is a clock cycle that's going through time. You can't stop this thing. This is a function of our existence. All the way to Cretaceous, say 468 feet. This is about a 200-foot difference between that and Triassic. Now, there's a reason why. And when I cover it in video series 4 on the cause of the Ice Age, I cover also where the water went and also where the water went on Mars. And what happened, what was the mechanism, and why the planet's further out. But you'll find out. And nobody else can tell you because no one ever figured it out but me. Okay, I've just presented to you, as quickly as I could, 5 different ways to prove that this 12,068 year cycle shows up. If Einstein's general theory of relativity was proven by merely the fact that his calculation was more accurate than the classic physics of how a light bent from a star that was behind the sun and then the edge during an eclipse, what I just showed you should have proved overwhelmingly that the universe is the product of information. Now, when you say this, it means that we're in a created reality, whether we like it or not. We're in a synchronous system. And I call this system the dihold. Hence, Dihold Foundation. Got it? The dihold. It's just the name I created 40-some-odd years ago to express a device, really it's like a computer, that contains the entire information for an entire universe, and it plays out. Now, there's a reason why. The rest of video 1 is going to be explaining the difficult stuff of what electrons are, what atoms are, how the atoms come into this dimension, defining dimensions, what magnetism, gravity, light is, photons, stuff like that. That's it. In video 1A, I quoted Richard Feynman and Lee Solomon about their prediction of what a new science or philosophy would do. You've only saw a little bit of it. The rest of it you'll see I have fulfilled what both their prophecy is. With that note, Dihold Foundation is a 501c3 science foundation. Yes, we do take contributions. You can contact us through info@diholdfoundation.com. The website is diholdfoundation.com. It has the expeditions on there and some of the other stuff. And anyway, I hope you enjoyed the video.